Good morning or afternoon. My name is Elja Makmandra and I will present my IR project. For question 1, this program reads a file from a storage directory, supports both a PDF and TXT formats, and prints the extracted text. It first checks the file type, PDF or text, and then it reads the PDFs using PYPDF2 and extracts text from all pages. It reads text files normally. It handles errors like unsupported files or empty documents. So first we run it for PDF, which is the p1.pdf1. So here is the output. Next we run it for the text files. And here is the output for the text files. For question 2, this program reads all text files in a directory and computes the TF-IDF scores after pre-processing. So first we download the required NLTK data, and then we initialize the stemmer and the stop words. We then have a function to read a PDF file and extract the text. We have the function to read, and then this is my function to pre-process the text. So I remove the stop words, also remove the punctuation, and also apply stemming. This is my function to compute the TF-IDF. This is the function to process all the PDF and text files in a given directory. This is to read and pre-process. Read file, pre-process the text, store, and then computes the TF-IDF for the entire corpus only once. So let's run it. So we have p1.pdf1, shows the contents and the TF-IDF scores. p2.pdf, the content, TF-IDF scores. p3.pdf, the content and the TF-IDF. p4.pdf, p5.pdf, p6.pdf, p7.pdf, p8.pdf, p9.pdf, and finally p10.pdf. For question 3, this program ranks text files based on a given query by the user using TF-IDF and cosine similarity. So how it works is just an extension of q2.py, the question 2 we just discussed before this. It has the stemmer, it pre-processes, it reads, it removes stop words, punctuation, and applies stemmings, and etc. So let's try to run this. First we insert the query for the first query. This is the output. Next we have the second query. This is the output. Finally, we have the last query. And this is the output. Next, for question 4, this program finds a frequent term sets for the query based on a user-defined threshold as well. So this is also another extension from question3.py. So let's try to run this. We use the first query. First, we use a threshold of 1. Now it shows, this is the output. It shows the frequency of each word, how many it's frequent in the documents. So frequent for one term set, which is like digit, it's in P8.pdf, P4.pdf, P5, P7. Same goes with the rest. And the two term sets, which is digit twin, digit gener, digit AI, it's all here. Gener AI. There's also a frequent 3 term sets, which is digit twin AI in document p8.pdf. So let's try to run it once more. We use the same query for comparison, but now we use threshold of 2. So if there is a term set that is not equal to 2, or if it's 1 below 2, then it won't show here. So here you can see it cut down a lot. Now we only have digit, gener, AI, because those term set has frequency of 2 or more. So we have digit in P5, P8, gener P6, P7, P1, AI P10, P2, P1, but no 2 term sets and 3 term sets anymore. For question 5, I will now explain the precision of the retrieval system which measures how well my retrieval system ranks relevant documents. So this is my code. This is also an extension from q4.py. So precision at the k tells us how many relevant documents appear in the top k ranked results. A document is relevant if it contains at least one word from the query. So our program does the following. It reads all PDF and text files in the dataset, processes the text, computes TF-IDF, ranks documents by cosine similarity to the query, and then identifies relevant documents, those containing at least one query term, and then calculates the precision K based on the user output. So how do we identify relevant documents? So for example, let's try to run it first. So let's say my query is the third query, which is quantum AI can be supported by IoT. It's with a frequency threshold of 1. And this is the output. So this is from the question 3. Now it shows the frequent term sets, and it shows the all relevant documents that contains at least one query term. So you can see here rank 8, 9, 10 has 0 cosine similarity, which means they don't have any, it is not relevant, so they don't have any words from the query. So let's say I put 10. So the precision is 0.7 because it is 7 relevant documents out of 10. And you can see here, this is the rank 1 P2 PDF. You can see they has quantum, they have AI, they can have quantum and AI lah. Then for P3, which has rank 9 and no cosine similarity, we can see that doesn't have quantum, doesn't have AI, doesn't have support, it doesn't have IoT, so it does not have any words from the query so it is not relevant. So that is all for my question 5, and that is all for my IR project. Thank you.